Welcome back. Aaron and Trevor with Astec Industries, and we're going to pick up on a conversation we just had the other day about the IntelliPac moisture system with Astec Industries. We're going to dive a little bit more into the sensors themselves. So, Trevor, what am I looking at, and how do we get to the point where we chose this sensor?
Yeah, great questions, Aaron. So remembering back to our previous video, this is a sensor for measuring moisture in your virgin cold feed material in real time at your asphalt plant. So what we've got in front of us is one of the sensors that we're using, and we had a lot of fun and a lot of good experiences as we developed this solution. So this is about 2.5 years in the making. Like we've talked about several times, this is not the first time that our industry has tried to come up with a solution like this. So decades and decades of industry knowledge and background that kind of culminated in the 2.5-year development process for this sensor specifically. We were fortunate enough to have a really excited customer that we worked with, that we partnered with to test these sensors. And when we did those field trials, we were looking for a couple really important things. Obviously, we know that a moisture sensor is going to measure moisture. We kind of take it for granted that the sensor is going to do what it says it's going to do. What we wanted to test was make sure that the sensor was going to be reliable and survivable in an asphalt plant environment. So one of the first things that we evaluated in that 2.5-year trial was where exactly we should put the sensor on the plant, and does it matter where you put the sensor on the plant? So the first place that we tried was actually a location that a lot of customers bring up with us. So we wanted to make sure that we tried that, and that was on the collecting conveyor, basically right at the weighbridge for the virgin material. So we put a set of sensors there and evaluated the quality of the data coming back, evaluated whether the sensors calibrations were drifting, what kind of things they were seeing as the plant operated.
And how many sensors did we actually test at the facility?
So on the weighbridge, we actually installed 4 different types of sensors, but those sensors were down selected from a much longer list of sensors that our engineering teams kind of evaluated on paper. We looked at a broad range of sensor technologies, everything from contact sensors that have been used on concrete plants for decades, all the way to cutting edge non-contact sensors like we've got in front of us right now.
And that's where we learned where to put these sensors?
Absolutely. So in addition to evaluating the performance of the sensors themselves, I mean, some of these sensors, they wore out in less than a month. So we learned really, really quickly which sensors were going to make it in this kind of environment and which ones were going to last a long time. The other thing that we were doing is we were continuously evaluating the data coming back from these sensors, and we discovered that a sensor that's put on the weighbridge is actually really sensitive to a lot of other parameters at an asphalt plant. Things like changing mix designs, things like changing the screen cloth on your shaker deck. All of these things that change upstream of those sensors impact the ability of that sensor to give a good and accurate and consistent reading back to the plant. So the solution for that was to move those sensors as far upstream as possible, which is why when we were at the plant the other day, you saw that we had the sensors actually mounted underneath the cold feed bins on those metering belts before the material drops onto the collecting conveyor. It's an easy place to put the sensors so that you can access them and maintain them, and it puts them as far upstream as possible, so you just have to calibrate the sensor for the material that's in that specific bin and not worry about all the other things that are changing at your plant.
So why did we pick this sensor? What else is this sensor, the features does it offer?
Yeah, great question. So the thing that impressed us the most about this sensor was, again, how rugged and survivable it is in an asphalt plant environment. One of the big things that contributed to that is actually this black portion that you see at the bottom. This is actually a dust shield. So what we're doing is we are feeding compressed air into this basically collar down at the bottom of the sensor. It's providing a positive pressure environment just past the lens, which keeps dust and moisture and all of these other things that are floating around in an asphalt plant from actually getting up and coating themselves onto the lens. So that was one of the things that stuck out really quickly. It made this sensor really, really resilient and robust in that plant environment. One of the other things that we love about this sensor is it's a smart sensor. So it's not just returning a signal to the plant controls and nothing else. The sensor is also tracking a bunch of internal health parameters, so that if for some reason something goes wrong with the sensor, we have the ability to dive into the controls for that sensor specifically and figure out what went wrong and use that to troubleshoot what exactly happened.
Also, a question that I've been asked a lot about these sensors is how often is it reading?
This sensor is pulling data and returning it to the control system, you know, hundreds of times faster than nearly everything else at your asphalt plant. So that was one of the things that we really took into consideration when we built this back into the controls and tied that data into the plant controls. We actually applied a smoothing factor to that data so that you can see these high-level trends in your moisture, which is what we're trying to capture, but you're not seeing the instantaneous chatter of that signal as it's looking at the different moisture of individual rocks.
Pretty important to look at that.
Absolutely.
Yeah.
Absolutely.
How should they get their plant prepared for a sensor like this?
Great question. So the elephant in the room is the controls. This sensor and our controls integration for the sensor is compatible with Astec controls back to about 2010, 2012 era. So kind of the origination of the PM3 controls and also the later generation PM2 systems. This is also compatible with all generations of the Mines platform, which is another Astec control system. Yeah. It is critical that the plant has Astec controls. You know, for us to be able to integrate that data into the plant controls, it's got to be on our platform. In addition to the controls, something else that your plant should be paying attention to is clean, dry, compressed air. For a dust shield like this to work, it doesn't work if you're feeding a bunch of wet, greasy air to the sensor. So the last big thing to talk about is the mounting to the bins. People ask us, you know, do you have to have Astec bins to mount the system? We actually have yet to install these sensors on a set of Astec bins. All of the systems that we have installed in the field so far have actually been on competitive bins. So our engineering team did a good job of making sure that our mount design was easily compatible with any of the different cold feed bins that are out on the market right now. So make sure that you've got Astec controls, but everything else is really, really easy to check off.
So we started off at the weighbridge. We moved to the cold feed bin. Another big question is, how many sensors do we need on a plant for it to work?
Great question. So really what a system like this is doing is it's helping you see the variability in moisture at your plant. That being said, you want to put sensors on the material that you're going to see a lot of variability, which is typically that finer material. Sands, screenings, really, really fine material that carries a lot of moisture. Coarser material, if you want to put a moisture sensor on them, that's great. You're just giving yourself that much more accuracy. But the reality is that coarser material, water drains out really quickly. There's not as much surface area to capture that water. So a static value that your operator entered is more than likely going to be accurate enough. So what we have seen in our installation so far, typically plants are putting 2 or 3 of these sensors on their cold feed bins. They're not putting sensors on the whole set. You just need to put sensors on that really fine material.
Let's talk about maintenance a little bit. What should a contractor look at or should expect for maintenance on one of these units?
So one of the main design goals that we had for a system like this is to make it as easy as possible for a plant to maintain and use them. We don't want to have a system that an operator is having to go out every day, or maybe they're worried that the calibration is drifting or something like that. We want to have something that's going to be pretty much hands-free. So again, 2.5 years of experience have told us that if you go out and wipe off the lens of these sensors once a month, once every 2 months, you're going to be in really, really good shape. You know, as an engineer, often we get into a place where we're kind of guessing about the maintenance of something. We've designed a system, but we don't really know how it's going to act in the field. We've got 2.5 years with this sensor, so I can tell you from that experience that wiping off the lens, that's all you have to do.
So we haven't talked about calibration. So tell us a little bit about calibration and what that's going to look like for a contractor.
Calibration is pretty straightforward. So when we initially set up these sensors, again, we're putting the sensors in the cold feed bins, so you only have to calibrate to the material that that sensor is looking at. The calibration process for these sensors is really straightforward. What we have seen is that it is possible to get away with only doing 2 calibrations for the sensors, a very dry calibration and a very wet calibration. However, these sensors perform best when you do 3, when you have a very dry, a very wet, and then you also do a calibration around where that material normally is. That way you've got a nice calibration curve that the sensor is able to use whenever it sees other moisture values coming through. One of the running jokes through this whole process, as we were supported both by the sensor vendor and also by our parts sales team, was that the calibration is so easy a sales guy can do it.
We did say that. I did say that a lot because it was easy. Trevor, thank you again for being here today to tell our story about the IntelliPac. Could you tell us the value a contractor is going to get out of adopting one of these systems to their plant?
Yeah, so a system like this, the name of the game is consistency and quality of your final product, of your materials. So whether it is making it easier on your lab personnel because they're not chasing their tail with AC content, they're not constantly calling back to the control house trying to keep up with, loaders dumping wet material into the plant, wet shipments coming from the quarry, an afternoon rain shower. Your lab operator's not having to chase all that. So you're making it easier on the lab guy. Not only are you making it easier on your lab, the plant itself is reacting in real time to those operational changes that every asphalt plant experiences. So if a high quality, consistent product matters to you at your asphalt plant, a system like this is absolutely a game changer.
To learn more, please visit our website or contact your Astec rep. Also, click on the link if you haven't watched our previous video about why moisture is important.